Glassmorphism is a popular design trend that blends translucent surfaces with frosted glass effects to create a stunning modern UI experience. It's widely used in web and app design to give interfaces a sleek, layered look while maintaining depth and focus on your content. In this video, I'm going to show you how to achieve this impressive effect in Articulate Storyline 360 using a touch of JavaScript, so you can bring this effect to life in your own e-learning projects. Hi, my name's Chris from Discovery Learning, and you are watching the Storyline Magic series for Articulate Storyline 360 developers. Let's get started here by launching a new project in Articulate Storyline 360. And we'll quickly run through the player settings first to turn off any extra UI elements around the player window that we don't need. The Glassmorphism effect works best when you are using a clear, in-focus slide background, so we want to avoid anything with depth of field in the image, for example. We can open up the Articulate 360 library for this, where we have thousands of images that we could potentially use as our background. I'm going to go for something with a circular design. I like this one, but if you'd prefer that the image have a different colour style, then we can do something about that by right-clicking on the image and opening the Format Picture panel. And here we can apply a blend colour with our choice of mode. For example, let's try a purple hard light. And yeah, I'm happy with that. Let's now draw our rounded rectangle card shape. We can centre align this within the slide using the options available in the Arrange, Align drop-down menu. And we want to apply a high transparency value to this, around 95%, as well as a light border around the edge. Okay, so to target this shape via JavaScript, in order to manipulate its style properties, we need to have an attribute which we can reference in our code. And at this moment, the best option we currently have in Storyline is to give our shape an accessibility text value and use this to target the containing div tag with a query selector method. We could open up the preview window and use the inspector console to discover another attribute we could use, like the data model ID, for example, that Articulate assigns to the shape after publishing, but this is more unreliable as the value can dynamically update if, for example, we ever cut and paste or make significant changes to our project later on. But who knows? Perhaps one day Articulate might finally listen to us and give us our own way of adding custom ID values to slide objects.
They ask you how you are, you just have to say that you're fine when you're not really fine, but you just can't get into it because they would never understand.
Let's carry on. I'm going to create my execute JavaScript trigger now, which I'm going to have activate when the timeline starts on the slide. Let's start things off by creating a variable for our rectangle shape. We'll reference the shape itself by using a query selector method on the document. And within the parentheses, in single quotes and square brackets, we'll type the attribute name data-acc-text. And instead of using just an equal symbol here, I'm also going to include an asterisk, which tells the method to include any HTML object that has at least what is contained in these double quotes in any part of the data-acc text value. Therefore, we can simplify our query by just typing a single identifier word from the alt text value, like rectangle. With that, we're now ready to apply any custom CSS style we wish to the object via our JavaScript. I'll set this up within an if statement, which will allow us to avoid generating scripting errors if for whatever reason the rectangle shape isn't found on line 1. If we simply type an exclamation mark followed by the variable name in the argument parentheses here, we're basically saying to perform the following action if the variable is undefined. In that case, we'll just log a message to the console to let us know the rectangle shape was not found. Otherwise, using an else statement, we can say what we want to do with that rectangle shape, which is to apply a CSS style to it. And the specific style rule we're going to be using in this case is the backdrop filter property, which, as you can see, allows us to blur or color shift an area behind an element, so it's ideal for creating our Glassmorphism effect. Let's type rectangle shape dot style dot backdrop filter with a capital F equals, and there are two key properties that we can play with here. The first is the blur value, which we can define the strength of in pixels within the parentheses here. Make sure to type this value within double quotes. We can go ahead and preview this right away and see the effect immediately taking place. It's amazing just how much the user experience can be influenced through the use of JavaScript in Storyline. If you want to see just how far you can push the boundaries working with JS, then you should definitely check out some of the Advanced e-Learning Developer Series courses offered through our website. More on that a little later on. A secondary option we can add here is a contrast value, which is a decimal value that we can set between 0 and 1. If I type in 0.75 for example, and preview this, you'll see that it starts to introduce some murkiness to the transparency, so a subtle use of this property can help you to create a frosted glass look. Have you noticed though that since we added the contrast value, that doing so has exposed a slight problem? As you can see in all four corners here, the effect we've applied is actually extending beyond the rounded corner boundaries of the shape. This is because, if we check this out using the inspector tool here, the effect we've created is being applied to the containing div for our shape rather than onto the SVG path itself. You might therefore be thinking, couldn't we just apply the style to the path tag instead in that case? Well, unfortunately that isn't possible, as the backdrop filter style isn't actually compatible with the SVG path tag. But don't worry, we have some options. The simplest thing we could do in this case would be to remove the rounded rectangles on the shape, of course. But let's not do that, and instead apply a border radius style to the bounding div box, which we can add by creating another style rule in our JavaScript here. But this time, the property we need is border radius, all one word with a capital R. Then we'll type equals, followed by a pixel value of, let's try 50 pixels, and preview this. Okay, we need a fair bit more, so let's take it up to 90. Just a little more, perhaps 95. Okay, that's more or less spot on, and now we know the default border radius of Storyline's rounded corner shapes. But don't go jumping back into the jacuzzi just yet, because things are about to get even more interesting for us if we try to resize our slide window, which, as you can see, affects our border radius proportionately to the width of the slide. Don't worry though, because JavaScript can once again help us with this. We just need to get logically creative to fix the problem. Let me show you how. So at full width in the preview window here, I can see that my parent slide div tag's width is 1561 pixels. So therefore we can calculate the scaling factor of the border radius to the slide width to be the value of 95 over 1561, which we can store to a variable called scaling factor. Now we want to know whatever the containing slide div's width might be at the time our JavaScript is ran, in case it might be smaller than this. So up top, we'll create a new variable called slide, and we'll assign our slide div tag to this using a document.getElementById method, with the ID name of the element written here into the parentheses. And now just above our scaling factor here, we'll determine the width of the slide at this moment using a getBoundingClient rectangle method. So by typing slide.getBoundingClientRect, open close parentheses, dot width, and a semicolon, we can get the width of our entire slide, which we can also assign to its own variable. Okay, now we can dynamically calculate what the pixel width of our rounded rectangle shape needs to be by multiplying the slide width value by our scaling factor value and assigning that new value to its own variable. This is just a number, so it doesn't come with a pixel or px label at the end. So when we bring this value in to replace our hard-coded value here in our style rule, we just need to make sure to concatenate the px text to the end using a plus symbol, and also ensuring that the letters are contained in double quotes. With that, we should now find, if we preview our project, that we'll see at full width we have the border radius still at 95 pixels, but reload the project to any of our available smaller screen sizes, and that effect will remain consistently snug with the border of the shape. That's looking great right now, but of course there's a chance the user might want to resize their browser window mid-activity. And we can account for that by simply wrapping up our entire if statement code here into its own function, which I'll call updateGlassEffect. By having the code contained within a function, we can now call it whenever we wish. We still want the function to fire as soon as the JavaScript is triggered, of course, so let's call our function by typing updateGlassEffect, open close parentheses, and semicolon. Then we want to call the function again if the browser window is ever resized, and we can achieve that in JavaScript by using an event listener assigned to the window property. So type window.addEventListener, capital E and capital L, and then in parentheses and single quotes, the name of the event we want to listen out for, which in this case is a resize event. Follow that with a comma, and then we can provide the function name that we want to trigger whenever this happens. So of course that would be our new updateGlassEffect function. We'll need to publish our project for real to see this in action this time, so let me show you the result of that in my own Google Chrome browser window. Okay, so we covered a lot of ground already. We have our shape, which we applied the custom CSS backdrop filter effect to via JavaScript. We then modified the style of the containing element in order to give this a rounded corner look, similar to the rounded rectangle shape in Storyline. And finally, we made the whole thing responsive and adaptive to resizing, so the entire effect works across any screen our users may have. We can go ahead now and use this effect as part of our slides composition. So let's turn this whole thing into a summary top tip box here with some additional text fields, an icon from the Content Library 360, and some additional rectangles with text. I'll bring everything together into a group by holding Shift and selecting everything from top to bottom here in my timeline, and right-clicking to create my group. Now if I perhaps have this group animate in nice and slowly from the right, when we preview this, you'll see that the frosted glass effect nicely applies to whatever is in the background as the whole card moves across the screen. What's more, we can have absolutely anything we want behind the card and the effect will always apply. So let's go ahead and bring in a video as our background this time. Again, try anything that you like. Something with fine detail that will blur when moved behind the card will really help to sell the effect. And there we have it. Have a go at creating this effect in your own articulate storyline projects. And if you'd like to continue developing your skills, then head over to the Discover eLearning website where you'll find our Advanced eLearning Developer Series courses featuring a growing number of full-length training courses built for storyline professionals. And be sure to like this video and subscribe to our channel for more content like this coming soon. Bye for now.